Welcome back developers and welcome back to OneCodeCamp channel. In this video tutorial, we will walk you through the process of creating a to-do list smart contract. And at the end of this video, you'll have a functional to-do list smart contract up and running. I hate to keep you waiting, so let's get started. In this tutorial, we'll be using several key technologies and tools to develop our smart contract. Here's an overview of what we'll be using. First, we have the MetaMask. MetaMask is a popular browser extension that serves as a wallet and a gateway to the Ethereum blockchain. It allows us to securely manage our Ethereum accounts and interact with decentralized applications directly from our browser. To easily switch between different Ethereum networks, we'll use chain lists. For our smart contract, we will use the Remix IDE. Remix IDE is a powerful IDE for Solidity contract development. Remix IDE provides us a user-friendly interface to write, compile, and deploy smart contracts directly from our browser. For testing purposes, we'll be using Mumbai Matic Test Network. The Matic Test Network is a dedicated test network that mimics the behavior of the Matic mainnet, allowing us to deploy and test our smart contracts without incurring any real cost. To simulate transactions and interactions within our to-do list smart contract, we'll be using test tokens. Let's start by installing MetaMask and creating an account. In your search engine, type MetaMask. Click Download. Click Install MetaMask. Click Add to Chrome. Now let's wait for the download to be finished. Let's spin it so that we can easily open MetaMask. Click Agree, and then click the Create a New Wallet button. Create a strong password. Once you're done, click Create a New Wallet. MetaMask will recommend to secure your wallet. This 12 combination of words or 12 secret recovery phrase is a piece of information that should be kept secure and private. It should never be shared with anyone, and the reason why I'm sharing this is because this is just a dummy account. To secure wallet, people normally save or write these words on the piece of paper. Now let us confirm our secret recovery phrase by typing the missing words. Finally, let's click Confirm. Now that we are done installing MetaMask and creating our wallet account, we will now proceed to changing our network. Let us first turn on the Show Test Network settings. To add network manually, click Add a Network manually. Now let's proceed to the chainlist.org. Let's toggle the Include Testnets. Let us type Mumbai. Now we can transfer this information to our MetaMask tab. But to make our life easier, we can just simply click the Connect Wallet button. And then click Switch Network. Now that we're done setting up our wallet, let's move on to the development of our smart contract. To do this, let's proceed to the Remix IDE. Remix IDE is an online platform that provides a user-friendly interface for writing, compiling, and deploying smart contracts. It is accessible through a web browser, eliminating the need for local installations and configurations. Let's start by creating a workspace. Let's choose a blank template so that we'll have a clean slate of our component. And let's give it a name. Let's name it My To-Do List Workspace. Or we can just name it My To-Do List. Click OK. We just created our workspace. Now let's create a Solidity file for our smart contract. Right-click on the blank space in the File Explorer. And let's give it a name, to-do-list.sol file extension. We can now start coding our smart contract. Inside this IDE, we have the File Explorer, Search tab, Solidity Compiler, and the Run and Deploy Transactions tab. Since our IDE is all set up, let's move on to the coding of our smart contract. We'll start with the comment of SPDX license identifier. In the line number 1 of our code, we specify our license identifier. MIT simply means that our code is open source license. It grants others the freedom to use, modify, or distribute our code. In our next line of code, we specify our Solidity compiler version. Caret 0.8.0 simply means that we are telling our Solidity compiler that our smart contract should run on version 0.8.0 or higher. After that, let's type the keyword contract and the name of our smart contract. Let's name our smart contract to do this. In Solidity, contract is like a class, and the curly braces indicates the start and end of our smart contract. Inside our smart contract, the first thing we'll do is declare the variables that we'll be using. Let's declare a data type address, set it to public, and let's name it owner. Set it to public. By declaring an address variable for the owner, we will be able to set later our wallet address as the owner of the smart contract. Now let's create a struct. Struct is a user-defined data type that allows you to create custom data structures. It lets you group together multiple variables of different types into a single entity. Struct is like a template of our variables. Make it simply, struct is like a folder that holds our variables. Inside this struct, we will place the data that we need like unique task ID, task content, and the task status. Let's give our struct a name, task. Inside this, let's type uin256 ID. And the string content. And lastly, boolean completed. We declare this set of variables and place it inside a struct that acts as a template. Here we have an ID for the task ID, content for the task or to-do content, and lastly, the completed will tell the user if the task is already done or not. The next thing that we will do is to create a mapping for this struct. Mapping is a data structure used to store and access key value pairs. Mappings are widely used in Ethereum smart contracts to efficiently manage and retrieve data. Remember that a struct is like a folder that holds information or variables. Imagine these folders being placed inside a bigger folder. Each folder will be paired with a unique ID for easy reference and easy retrieving of data. Now, going back to our code, let's type mapping uin256 let's place an arrow and then the name of our struct task. Let's set it to public. And then the name of our mapping task with the letter S. I also have an error here. This should be capital T. For us to be able to track how many tasks does our smart contract have, we will create a new variable task count. Every time a task will be added to our smart contract, this variable will increase its value. To do this, let's type uin256 task count. Let us also set it to public. The next thing we'll do is we're going to create an event. Events in Solidity are used for emitting information from a contract that can be captured and processed by external systems or interfaces. Let's type in event. Let's name our event task created. Inside this event, we will pass parameters that we want to emit along with the event. These parameters provide additional information about the event. It allows you to pass relevant data to the external systems or user interfaces that are listening to the event. Let's type uin256 ID. string content, and a boolean completed. We will also add another event named task completed. And inside this, we will also emit uint256 ID and a boolean completed. I forgot to add 256 on this one. And we're done declaring the variables and events that we need for our to-do list smart contract. The next thing to do is we're going to add functions to our smart contract. Let's start with a constructor. A constructor is a special function that is automatically executed only once during the contract deployment process. It is used to initialize the state variables of the contract and perform any necessary setup or initialization tasks. To do that, let's type constructor, followed by open and closing parentheses, and an open and closing curly braces. And let's assign the value of owner to the message.sender. msg.sender or message.sender refers to the wallet address that triggers this constructor function. In our case, since we are the one who's going to deploy the smart contract, the owner will be set to our wallet address. And that's it for our constructor for now, so let's move to our function. First, let us type function and the name of our function. Let us name our first function createTask. Let's set it to public and add opening and closing curly braces. In this function, we will pass a parameter, so let's type in string_content. Also, let's type the keyword memory. Memory simply means that the data will only exist only during the execution of this function, so it is like a temporary memory. Inside this function, let's create a requirement that only the owner can trigger this function. To do that, let's type the keyword require. The require statement in Solidity is a way to validate conditions within a contract. It is commonly used to enforce certain requirements or constraints before allowing the execution of a function to proceed. Having that said, if the condition is not met, the codes below in this require statement will not push through and the changes will be reverted. Inside this, let's type message.sender is equal to owner. After that, let's type comma. And let's add 2 double quotation. Inside the double quotation, let's type a message only the contract owner can create tasks. You may also notice that there are yellow lines. You can ignore that for now. That is actually just a warning. It only means that we have a declared variable name _content and the IDE is just reminding us to use it. The next thing we will do is we're going to increment the task count. Task count is a state variable that we will use to keep track of the total number of tasks created. By using the increment operator double plus, the value of task count is incremented by 1 each time the createTask function is being called. After incrementing task count, a new task will be created with the updated value of the task count as its unique ID. Now, let's access task mapping using the current value of task count as the unique key value pair. To do this, let's type task. Inside the task, let's type task count. After that, let's assign a value to the task ID, task content, and task status by accessing the task struct. Oh, I forgot to put an S on this one. The last thing that we will do in this function is to emit the task created event. To do that, let's type the keyword emit and type task created. inside this, we will pass the task count, task content, and task status. And that's it for our first function named createTask. With this function, we can now add tasks to our smart contract. Let's have a recap on what are the codes that we have placed in our createTask function. First, we created a requirement that only the owner can access this code. After that, we increase the value of the task count variable every time that this function is being called. Next, we added a task by assigning a new value to the task struct, which consists of ID, content, and status. And lastly, we emitted the task ID, task content, and task status to inform the external interfaces, like a front end for example. The next function that we will add is the function completeTask. This will change the value of the variable completed from false to true. Again, let's type the keyword function and let's name the function completeTask. Let us pass the parameter task ID into this function. Let us also set this function into public. The next thing that we will do is to check whether this task ID is existing. We can do that by ensuring that the task ID is within the range of 1 to the total of task count. To do that, first let's type require. Within this require, we will set a condition. Task ID should be greater than 0. And task ID should be less than and equal to task count. If the condition will not be met, we will send a message invalid task ID. Once the user enters a valid task ID, this function will push through. Otherwise, the function will be reverted. The next thing that we will do is we will create a storage reference to an existing struct in the mapping for efficient modification. Now that we have a reference or access to the task struct, we can now update the value of our completed variable. To do that, let's type task.content and let's assign the value of true. Let's also emit the task completed event. Inside this event, we will emit the task ID and the value true. We might also want to restrict this function to the owner so that only the owner can use this function. The same thing that we did in the createTask function, but typing that line of code again and again is repetitive and inefficient. So what we're going to do instead is to create a modifier. Modifiers in Solidity are used to add additional behavior or conditions to functions. They allow you to enforce certain requirements or restrictions before executing a function. To do this, let's type the keyword modifier and let's name our modifier onlyOwner. Inside this modifier, we will place the restriction onlyOwner. Actually, we can just copy the code that we have created from this createTask function. After this require statement, let's place underscore on the next line. In Solidity, the underscore inside the modifier is a special character that acts as a placeholder. We can now remove this. And we can now set this to onlyOwner. And we can now also set this to onlyOwner. Basically, we can set this modifier to any function that we would like to place a restriction. The next function that we will add is a function to delete a certain task. Let's create a function and name it delete task. The same with previous functions. Let's pass a task ID. Let's copy this require statement and paste it inside our delete task function. To delete a task, let's use a delete keyword. The delete keyword is used to reset a storage variable or delete an element from a mapping. By the way, we are having an error because I forgot to set our function to public. Let us also add onlyOwner to this function. And lastly, let's also emit an event to this function. This time, let's emit the task ID. You will see that we are having an error because we are not yet declaring our delete event. Let's create an event for this. Let's type event task delete. And inside this, let's pass the task ID. You will see that the error is now gone. Now that we have a delete function, let's also create an update function. Let's type function and name it update task. Let us set it to public. Let's pass the task ID and the new content. Same what we did a while ago, let's copy the require statement and paste it inside the function. To update the content field, we may copy the code from the line 34 that we used earlier, or you can just type it manually. Then let's assign a new value to the struct variable. You will notice that these codes are just similar. And lastly, let's also emit an event for this one. Let's also create an event for this one. And we are almost done. We will just need to add a few getter function to retrieve this data. First, let's create a function getTask. And let us set it to public. And let's type view returns. A view function is a function that does not modify the state of the contract, while the returns keyword is used to specify the return type of the function. Inside this, let's return a string memory and a bool. Let us pass a task ID. Again, let's copy the require statement. Let us again retrieve the task data with the given task ID from the task mapping. And then let us return the data that we would like to retrieve. Now let's create a function that will retrieve the number of tasks stored in our smart contract. Let's create a function and name it getTaskCount. Let's set it to public view. And let's return new int 256. Inside this function, let's return the task count. And that is all for this function. Our last function will check if a given task is already completed or not. Let's create a function and name it isTaskCompleted. Let's also set this to public view. And let's return a bool. Inside this function, let's pass a parameter, task ID. For the last time, let's copy the require statement. And again, let us retrieve the data in the task mapping using the task ID. We can just copy this one. Finally, our last line of code, let us return our completed status. And we're done creating our smart contract. Now it's time to test our smart contract to ensure that everything works as expected. To do this, let's proceed to the Compile tab by clicking the S-like icon. From this tab, let's click the Compile button. Once you're done compiling, you will see a green check mark indicating that our smart contract is free from errors and ready for deployment. We can now move to our Deploy and Run Transactions tab. From the Deploy and Run Transactions tab, let's proceed to the Environment Setup. Let's click the environment and select the injected provider, MetaMask. You will notice that our MetaMask is now connected to the Remix IDE. Click Deploy to deploy our smart contract. Let's wait for our smart transaction to be deployed. The green check icon at the bottom indicates that our smart contract is already deployed or published to the blockchain. We can interact with this smart contract by clicking the Expand button. Using this interface, we can now interact with our smart contract. Here we can see the owner. Then the total task count, it's 0 at the moment. Let's try creating a task. Let's type going for a grocery. And let's click the create task function. Confirm the transaction. Let's add another task. How about this time going for a morning walk? Let's add another one. How about plant some trees? Let's click the task count function and you will see that we have a 3 tasks stored in our to-do list smart contract. For the last time, let's add another one. How about eat my dinner? You will see that our task count is increased by 1. We can also check our tasks using this button. Let's also try to complete a task. And you will see that the completion of this task is already true. We can also use this function to retrieve a task details. Let's also try the update function. And you will see that the content of this task is already updated. And let's try our last function, the delete task. And finally, the content of this task is already removed from our data. And that concludes our video for today. Thank you for watching this tutorial, and if you have any questions or suggestions, please leave them in the comments below. Don't forget to like this video and subscribe to our channel for more exciting tutorials. Once again, happy coding and see you next time.